we would like to welcome our speaker, Mr. Sumit. Sumit is a Deputy General Manager, Automation, Artificial Intelligence at Voice. Sumit will be delivering an interactive talk session on AI agents shaping the future of quality engineering. To know more about Swaroop, please check the below link. Swaroop, it's over to you now.
Sorry, that was Sumit, and Sumit, you can take it over from now.
Yeah, Sumit, it's fine.
Thank you, Komal. Thank you, Dipti. Let me just share the slides and everyone of you can confirm if it's visible. But,
We can see you, but your slides is yet to
Um,
be.
now I'm just sharing. Yes, Dipti, if you can confirm, visible.
Yes, we can see.
All right, great. Thank you. Okay, welcome everyone to another topic around AI agent. So, let me quickly take you because there are a lot of content. So, I will quickly move to the agenda, and with that, I will try to set the context here. So I think we will be talking about the rise of AI agent, and I think uh, it itself explains to all of you that why it is so significant and important to talk about AI agent nowadays. I think last year, uh, mostly last to last year, I can say it was an era about talking only about GenAI and all stuff. But I think all of you must have heard about AI agent or agentic AI and also a lot of things around MCP server, which we have seen in the last session. So I think I will be talking about that, about some interesting fact, what we're gonna see in terms of future and how AI agents are going to redefine entire quality engineering and overall IT stack altogether. With that, we will be talking operating principle in terms of how AI agents work, right? So I think this is a very important thing all of us sometimes struggles to understand the core principle behind it. So I will try to give some lights around it, and also I will try to focus around if anyone wants to do development, then what are the key things will be coming in your way if you are creating any sort of AI agents. We will be talking about AI agents types, right? Most of the times it happens that people try to build something, but every agent has its own type, and basis on the type, it is very important to have that structure and framework design. So we will be talking in a nutshell so that one of the takeaway of the session is like if you are creating any agent, at least you should be able to signify or distinguish, okay, my agent is coming in which area, what exactly I can achieve from this. And then if you know this, then how you can have, multiple agents talking to each other and concept of agentic AI you can develop. So we'll be touching on that part. Some of the key use cases which we often see as a quick win in quality engineering. Believe me, there are a lot of use cases. So this slide is just as a, I would say input to audience that, okay, these are some of the use cases which are proven. You can try, okay, because this will be quick win for you. But at the same time, use cases are not limited to it. I think we all know there are a lot of AI agent use cases are there. But basis on the return of investment and quick win in quality engineering, I thought to keep some of the use cases for everyone's information. We will touch base at very high level about what is the significant difference between agentic AI and AI. Something the way we used to, speak everything as Gen AI few years back, but there is a very big difference between Gen AI and traditional AI ML. So similarly, I thought it is important to share with the audiences like, okay, what is the significant difference between these two terminologies, which often, interchange and somehow, the meaning or the context of agentic AI uh, getting lost. And I think I thought I will talk about that. Of course, AI has lot of issues, challenges. I think we know model hallucinations and all. So particularly with respect to AI agent, most of the things comes as is from the things which we know as AI ML challenges. But here I will try to talk about specific challenges which you should know, or maybe I would say rather than challenges, the proactive measures which one should adopt when implementing any sort of AI agent, and then we'll go for Q&A. So with that, I think let me start my topic. So yeah, I think I don't need to explain the importance of AI agent. The conference itself is, I see a lot of topic around AI agent, same way we used to see like Gen AI topics. So it itself explains that what is the current ecosystem of AI agent. A lot of companies and organizations have already started seeing a lot of return of investment for some basic AI agent. Gartner itself is predicting by 2028 almost 33%, enterprise software applications um, will, try to cooperate like 50% of day-to-day job autonomously. And I think these figures may increase a lot. Also, there is a prediction again from Gartner that 40% of the enterprise applications will feature AI agent by next year. Okay. So all these things are already pointing us that we are now in the era of AI agent, and not only for quality assurance, I think for entire software industry, everywhere AI agents are coming because of the adaptability, because of the nature where they can do the jobs very easily, and kind of a workforce, I would say, where whatever few things you used to do from the prompt, maybe when the time of Gen AI, or let's say when we use ChatGPT, I think somehow the results are coming by AI agent, which we will see as an example, how those kind of agents are already there, and how this kind of an agent, if you try to use in your day-to-day practice, can already start giving you the results. Okay. With that, let's try to understand the key operating principles around the AI agent. See, there are four key principles on top of which any AI agent sits. It starts with something which we call perception. Again, I will try to simplify all the keywords and definition in a very simple word. It only means that, input, right? So it could be input from various sources. It could be your text, it could be your audio, it could be some instruction, it could be some triggers, right? If we talk about some autonomous or maybe automated AI agent flow, like there has to be some ticket which has to be raised if this kind of a notification is coming. You can consider that as well as an input. So input is not just text, and I think this is very important. Perception means AI agent relies on that kind of input, which becomes a base for further action. Second key pillar comes as reasoning and decision making. I think here we all understand that there are a lot of machine learning model building comes into the picture, where reasoning, decision making, the outcome, whatever you are getting from your form happens here, right? Now, this itself, reasoning and decision making box has a different layer. I think you have seen also in previous session, MCP server, we talked about the RAG and all. I will try to simplify with another example, like how this reasoning and decision making box is one of the, I would say, heart of any AI agent. But yeah, the overall principle goes like, okay, you have an input, then you have a reasoning and decision making, and later you do some actions, right? Which means you generate some sort of text. If it is text-based AI agent, you produce some sort of output, maybe some actions are getting performed, and then your agents basically go into learning and feedback mode, where from various contexts, right? I think one of the things which we all know, even if when it is a Gen AI, there is a contextual, loss, or maybe you have some sort of uh, issues in terms of getting the feedback from the right, prompt. I think that goes similar to AI agent, where basis on your outcome which you are getting from the AI agent, you try to make it into kind of optimized way. Now here when we say learning and feedback, generally in terms of AI agent, it is quite different because it is all about the context. It is all about some sort of model hallucination, and then some sort of angle which you bring from your development, right? So if I give you an example of let's say Microsoft AI Agent Builder, right? And if you are creating agent there and you are not getting the right outcome, then you will try to give that configuration or file information into the settings, right? And that is how you will understand that, okay, if a person is asking this which is out of the boundary, then I might need to give some safeguard over there. This is an example. It is not like you are just using AI agent and it is learning. It is like you are deploying the agent, you are getting the feedback, whatever feedback you are getting from the evaluation, You are coming into wherever you are creating the agent. Now it could be Microsoft AI agent builder, it could be, Copilot Studio, whatever it is. There you will try to do some sort of configuration, some sort of inputs and all, and that's how you will try to build the agents around it, right? Now to simplify this in a simple way, when it comes to operating principle, or we say about if anyone wants to develop the agent, I think some of the things which all of us will see is a prompt. So everything starts with the prompt, and consider this is kind of a LLM based agent I am trying to talk about developing. So you give a prompt and it goes to sort of LLM model. Now examples could be you can have GPT-4, GPT-5. These are some of the example I am just speaking, right? But consider that your prompt goes to sort of LLM model behind. Okay, LLM models basically try to create some sort of a decision making based on some other parameter behind it, which is the infrastructure. So model will talk to something. It could be rack, it could be your API gateway, it could be MCP server, which we have just seen maybe in the previous talk, where there is a model context protocol server has been set up. I will try to also simplify this thing. You consider it as a client server based mechanism where a client which is hosted in your own application is talking to one of the server, and that server is having all the resources, environment, data to provide the feedback back to your client, which is again the MCP client hosted in your own application. Now this is nowadays a very popular mechanism, but yeah, it could be a simplified API gateway, it could be your local databases, it could be rack, anything sort of things, right? So prompt LLM model, then going to infrastructure, and then again infrastructure is talking to something which is your database, right? It could be vector database, it could be your some simplified file system, SQL type databases, or maybe the plain, if I say about some agent builder, it could be Excel file, CSV file, or maybe Microsoft list, whatever. It depends on your infrastructure basically, right? And if you do that, then generally you go for agent evaluation. Now, which itself is a big topic, but you consider here the way we do any sort of AI evaluation where a different scores are present, which you all know, like a algorithmic some formula. There is a quantitative-based evaluation, qualitative-based evaluation. Hybrid models are there. So your agent also goes through all these things in terms of evaluation, and then you try to deploy it in terms of your environment, like productionizing it, right? So in a simplified way, if you want to always understand how basically AI agents are built, okay, the top diagram explains you. It goes through four key pillars, right? Your input, logic, decision making, and then you generate some sort of outcome. And wherever you see any gap, you have some learning and feedback arrangement, which is basically a configuration, okay? And as an example of a infrastructure based agent which you are deploying in an organization, you will often see such kind of an architecture again in a different way, but in a simplified way. I think the core is LLM model talking to infrastructure, which could be your MCP servers or your API gateway, which is talking to your database, rack, vector database, or file system. Around these things will happen, okay, and then again, it depends, like few more things are there which I have not added here just to make it simplified, but there are some more things also here, like safeguarding your input outcome. If you are creating agent for a particular task, you don't want agent to give outcome for some other area. So here you will use some sort of, let's say, regular expressions or coding. You can consider like that, where you will tell that, okay, if these kind of things are coming, then you don't want to give any outcome, or you want to maybe change the prompt, right? Or a suggestion you want to provide to end user. Well, if we understand the operating principle and the development methodologies around agent, it is time to understand different types of agent. Okay, so I am trying to simplify here. Types like simple reflex agent. Again, will not go into lot of terminologies like what is simple and reflex and all, but you just consider these are the agent which doesn't rely on any history. Okay, just to remember always that these are very, very context bound. They only will work basis on what input you are giving in the current situation and produce the outcome. They don't know the history. They don't work on the history. Okay. On the other hand, When we talk about model-based reflex agent, here the models comes into the picture, okay, and you have certain references from the historical data. You can consider these as an analytics agent, or you can consider it like, okay, you want to, let's say, do some sort of, date, like let's say you have a historical data of your information. It could be your defect, it could be anything, right? And you want to get some insight out of it from the agent, okay? Now, this kind of thing, when you are creating, it will go into the box of model-based reflex agent, okay, where you are working on the historical data. There are a lot of aggregation functions are involved, a lot of mathematical or calculus are involved, and then you are trying to get some sort of output, okay. Uh, then come a goal-based agent. Often we also categorize or try to say conversational agent, where you are defining that, okay, I want to get this action done. This is my particular goal, and I want a result around this, right? So agent will use something from their own, model understanding. Then it will use some database. It will do their own logic, and it will only be working for a particular goal to be achieved, right? So after the instruction, you will just you will just expect agent to perform a particular action or a goal, okay. Then comes a learning agent. Generally, if we talk about autonomous agent, which is the next category, learning agent also start as a fundamental agent model before the autonomous agent. So I will try to cover autonomous agent, which itself will explain you what is learning agent. So in autonomous agent, it is all automatic. So basically, it's agent who is learning from the environment. Or if I give you one of the example, you consider a basic prediction model or a prediction agent is able to do. Then from its own environment, it is trying to learn, take the input. So perception is also its own, do the reasoning, logical understanding, and give the actions, right? So it is completely autonomous in nature. Okay. We will see what category it comes into. It comes into agentic AI category, but you consider that is what the whole goal of autonomous agent. And learning agents are basically the foundation, I would say, agent which are completely based on just learning and feedback. So it's like whatever you give them as a learning around, only that it will give a feedback. So it's a controlled agent. You want information, let's say from Jira, Confluence, or something, then you will go with this category. Okay. Now, again, to explain this category in a simplified way, generally we call agent then classifies into something like a predictive agent. Now, predictive means you have to provide some sort of prediction based on the historical data. You want to do clustering, classification, prioritization, right? So that will also come into this area. Now, what is important here to understand, we have seen in the operating principle, the core base is the foundation model, right? So here, any predictive AI agent which we are building will go from some classical model, predictive models, or I can say a sort of different machine learning model which relies on the pattern. Okay. Similarly, there are generative, which works on the concept of LLM, GAN, anything which you want to generate, right? So this sort of models are there. And I think then there is another category, which is autonomous agent, which we have discussed in length, which you can consider as model which are relying on reinforcement learning, right? So basically, MBRL, RL are nothing but the short form of reinforcement learning. So model-based reinforcement learning, or you can call reinforcement learning, has another part which is MBRL. And in this area, basically, whatever you want to do from GenAI, which we learned in the story of reinforcement learning, or maybe the agent which want to be autonomous, there they will fit. So these five categories generally goes into these three boxes, and then it will help you to understand, okay, your agent comes in which category. And if we talk about the last things like the use cases, so these are some of the key use cases for you if you want to quickly build something around it. I think we know about code generation, code assistance like Copilot, agent-based code review and code optimization can be performed. This can go into the goal-based agent. Report analysis, log analysis is sort of agent which are basically working on historical data. So model-based reflex agent, then creating some PPTs and the document, goal-based agent, agent helping in project planning and tracking. Again, we can call as goal-based agent, right? And then doing something like automated support ticket or user, creating a ticket. So it can be simple reflex agent where you are giving a task and you are expecting some sort of outcome. Well, with this use cases, the last thing is all about, I think not last, before that, a difference between AI agent and agentic AI. So I will not take much time here, but you can consider agentic AI is all about autonomous. So they are basically complex. They are created for complex tasks. They have the continuous learning in nature. They highly adapt to dynamic environment changes and all. On the other hand, AI agents are basically rule based. Okay, so you need human intervention for AI agent. On the other hand, when we talk about agentic AI, it's completely without human acting on their own. Okay. And now, if we talk about the challenges, I think we all know some of the, challenges which comes in the form of AI that goes same to AI agent in terms of data biasness, adaptability of AI agent, complexity in integration. If you are integrating them with different tools, the Jira, Confluence, you will be requiring some connector, or you might need to work on some sort of automated way to do that data and show something dynamically. As an example, monitoring challenges are there for autonomous agents. There are a lot of observability tools, but again, there are some challenges which you need to look for. Regular maintenance and updates around AI agent security and compliances are also important things to know. And one of the key factors, if you are going in any sort of multi-agent things like agentic AI sort of thing, you will get a model hallucination. You will get some sort of context, breakout things, and these things will often come over there where you need to fine tune all agents for a specific goal. Okay. So these are the challenges around all the AI agents which I wanted to share, which will help you before implementing any sort of AI agent. And yeah, with that, I think we are open for Q&A if we have any time. I hope we are on time.
Yes, Sumit, we are on time.
Yeah.
Participants can help us with questions on chat. But Sumit, in the meanwhile, I think you were talking about the challenges that you faced while you guys tried integrating it also. Would you want to kind of also tell how did you overcome that?
Well, see, I think I can say some of the challenges. For example, when we talk about that data, I think the most important challenge is if you are creating any sort of AI agent, maybe you do data mapping and cleanup, but you are not getting all those kind of a result. Maybe you have 100 results which you already know, but agent is not giving those results. It's a partial, right? So in that situation, I think the most important thing is we have to have a very good data mapping. And in terms of agent configuration, you need to deal in a very sophisticated way because end of the day, agent agent works on some principle and model. And when you create your databases all together, there are a lot of layers comes as an organization, like your security policies and all, which will restrict model to perform the way it is. If you talk about implementing something in the open world, it will be quite easy, but you bring it to some organizational practices, right? And that kind of a data layers and securities are there. The same model which you see often working now will start giving hallucination, right? So these are just initial hiccups, but my suggestion is if we know these core principles, then you can adopt. So for example, if I want to get something dynamic from Jira, I will not create a lot of automation layer. Rather, I will sit with Jira connector for AI agent, right? Because that is proven, right? So a lot of experiment can be avoided is my observation or thing to tell to audience. Don't jump into saying things. Have your goal very clear, and basis on that, if you go and create something, I'm sure it will give you the results. Okay, right.
Also, another question: how do you think AI agents can help predictive quality and defect prevention? Have you
See,
seen this working for your or?
I think I will go to the second part first. Defect prevention sort of AI agents are, I think, still in kind of, I would say, protocol based because a lot of information or access is required. let's not talk about AI agent itself. Even if we talk about GenAI as a principle, and we say that okay, I want to predict the defect, right? To predict a defect, fundamentally you need code access, right? And generally, what happens in any sort of big organization, you have different vendor, different ecosystem, you have data security, compliances, and all, right? So yeah, in isolation, if I have my own code base, and on that, if I want to do some defect prediction, yes, models are there. They are giving the predictions that okay, this code can give this sort of effect. But having said that, if you implement that in the organization, you need to consider all these aspects. If you are just thinking from historical defect, I am going to do defect prediction, I think for me it is not defect prediction, it is statistics, right? You are just uh, saying that, right? So that was your second question. And the first part which you talk about predictive analytics agent, I think they are very mature, Dipti. To be very honest, I think these are the quick win. In fact, in my use cases, I have shared one of the use cases on predictive analytics, wherein yes, if you have your historical data source, agents are very good in terms of doing some logical understanding and recommending you something. For example, you can ask them which are the priority things I should test, or what should be my regression pack out of this. You will get a lot of good answer, which will help in your project planning and delivery. Okay.
Okay.
Any further question?
No, Sumit. Thank you so much for sharing your insights and thank you for outlining it really well.
Thank you, Dipti. Thank you, everyone.
Thank you.
Thank you so much, Sumit. Yeah.
I don't think Komal is around, so I will just go ahead and do this. Thanks, Sumit.